Hi and welcome to a two-part video about specific heat capacity and the coefficient of linear expansion. Now, many people saying to me specific heat capacity is a concept I don't understand. Right, I'm going to put these in very easy terms for you to understand. One thing you need to remember is to size various of plumbing components such as boilers, radiators, you need to understand the concept of heat. Okay, so this particular part of specific heat capacity you might be need for future units such as hot water, central heating. Okay, so heat is different from a temperature and is measure of the amount of energy in a substance. As you well know, the standard unit for measurement of heat is a joule. So specific heat capacity is an important principle for every single one of us, every single plumber to understand. So specific heat capacity is all about the amount of heat energy required to heat up a substance by 1 degree. As long as you know the specific heat capacity, we know the amount of the substance and we know the temperature rise. So the temperature rise is the one actually gives you our specific heat capacity. Okay, so it doesn't matter if you are using a kettle to heat up hot water or you are using a hot water cylinder to heat up hot water, or you are using a heat exchanger such as copper heat exchanger or cast iron or aluminium. Each one of them has a specific heat capacity, and does so water. So what I want you to note, I got a table here and the water requires a lot more energy to heat up than any other material. Also you can see from this table, okay, copper has a very low specific heat capacity, so therefore it doesn't need so much energy to be heat up. Now then, this table here he has given, this value is not changing. Is the water, specific capacity, aluminium, copper, cast iron. You got all of these values, and these values, that's the ones you need to do the examples later on at the end of this video. Okay, so we're going to refer to this table later on. Right? So the criteria we are looking to answer any question to get the specific heat value of any material is the specific heat value itself, the amount of the material. And the amount of the material could be weight, and that is in kilograms, or is used in a hot water cylinder, which might be a volume. So you might have 100 liters of water. Well, what we need to know is convert liters into kilograms. So we know 1 liter of water weighs 1 kilogram. So therefore, if you have 100 liters inside of your hot water cylinder, that hot water cylinder will weigh 100 kilograms. Therefore, we have got the specific heat value in kilojoules. You have got the weight of the water in kilograms, and now you need the temperature rise. So the temperature rise, that's a crucial point here. That's the one we need to work out the specific heat capacity. Now, you need to be very careful. It's the temperature rise we need, not the start temperature, not the final temperature. Okay? You might have to take two temperatures away from each other to get the temperature rise. So, I got an example here, right? So my example is very simple to understand, right? How many kilojoules would you take to heat 100 liters of water from 30 degrees to 80 degrees? Now then, as you can see, I underline 100 liters, I underline water, I underline 30 and 80, okay? So don't forget, the difference temperature is that, okay? So we got a difference temperature, we got both temperatures, so take the difference. We got 100 liters of water, and water is the material. So if we go back to our previous table, water the specific heat capacity of water is 4.186, and that will stay the same. It's not going to change. Now then, how do you work out this answer for this question? Now then, I got a simple formula here. You might be saying, well, formula, oh gosh, I don't understand any formulas. Now then, I'll put this in an easy way, very, very simple. So we have liters, so liters, a temperature difference, okay, which is that, all right, 80 and 30. So if you take 30 from 80, it will be 50, okay? And you got the specific heat capacity of water, which is 4.186. Now, to work out the answer for that question, all right, you got 100 liters times the temperature difference, which is 50, times 4.186. So, which gives you 20930 kilojoules, right? Okay, it's very simple to work out. Now, whatever material you do, you use it exactly the same way. All this is not going to change as long as you're referring to that table to see the specific heat capacity of the material you are about to do. Also, many people ask me as well, which power required to heat up the water in an hour? Now then, assuming there is no energy lost, okay, in a system, all right, so an hour contains 3,600 seconds, right? Now then, so we're going to convert kilojoules to kilowatts, and the best way to do is using the answer here given, which is 20930 kilojoules, right, dividing by 3,600 seconds, and it gives you the value in kilowatts, which is 5.81 kilowatts, okay? That's what you use to heat up a system in an hour, okay? Assuming there is no energy lost, right? Now, the best way to do is practice. The more you practice, the more you become better and you understand clearly what it is, okay? I hope you find this video helpful and informative, and I will see you soon.